Okay, I hope I'm audible to all my students who are attending this particular lecture for the Intermediate Microeconomics Part 1 course. In this particular lecture, I'm going to continue with the discussion of the 2024 question paper, which has come up at Delhi University for the Intermediate Microeconomics Part 1, currently offered in semester 3 of BA Honors Economics. Now, all my students can recall that in the previous lecture, we had just started with the discussion of this particular question paper. Remember, it contains two sections, section A and section B. Okay, so we had looked at the format in the previous lecture, just quickly revising it. Section A, okay, students need to answer any three questions from this particular section, and section B contains questions where you only need to answer two questions from section B. Okay, in the previous lecture, we had started with discussion of problems from section A. We were looking at question 1, part A. And within part A, I had solved these two subparts in the previous lecture. Okay, now in this particular lecture, we are going to look at parts 3 and part 4. Okay, what was the question for these utility functions? We had to identify whether the preferences are monotonic and convex. And in my previous lecture for this particular question paper discussion, we had revised the definition of monotonicity and convexity. Preferences are simply said to be monotonic if given any two consumption bundles, the consumer prefers that consumption bundle which contains more of at least one of the goods but no less of the other. So more is preferred to less simply. Okay, and to check for monotonicity, we calculate the marginal utilities. If the marginal utilities turn out to be positive, it means that increasing the consumption of that good increases the total utility. Remember, positive marginal utilities means total utility increases as consumption of that good increases. That means more is preferred to less. So we had calculated the marginal utilities for these two utility functions, and we had shown that since they're coming out to be positive, the preferences are monotonic. For convexity, the weighted average of two extreme bundles should be preferred over those bundles. That means given any two bundles, given any two extreme bundles lying on the indifference curve, if I take a weighted average of them, the weighted average should lie on a higher indifference curve. Then only we say that the preferences are convex. Okay, for the first one, we had found out that the preferences were convex, but for the second utility function, preferences were not convex because averages were not preferred to extremes. Okay, so we had done these two parts. Now let's quickly start with the discussion of parts 3 and 4 in this particular lecture. So let's look at part 3. Utility function is y over 100 minus x. Let me quickly come to the whiteboard and let's check whether the utility function in part 3 is monotonic and convex. I'm just writing the main heading for completeness, just for clarity. Delhi University exam 2024. Name of the course is Intermediate Microeconomics Part 1. Intermediate Microeconomics Part 1. This is currently offered in semester 3 of BA Honors Economics. Okay, so we are looking at question 1, part A, part 3. We are given the utility function in x and y, which is y over 100 minus x. Okay, now let's quickly plot it first of all. So suppose I fix a utility level at say u bar. Suppose, because only when we plot it we get an idea of its behavior and convexity and monotonicity. Suppose we fix u of xy equal to u bar. Remember, utility is always constant on the indifference curve. So I get u bar equals y over 100 minus x. So what is y? Let's quickly see what is y going to come out as. So y is going to be 100 minus x times u bar. Now let's take a value of u bar for simplicity. Say u bar is equal to 1 for simplicity. The most simple value I can take of u bar is 1. So therefore, what will y be? It will be 100 minus x, right? The moment I put u bar as 1, y will be 100 minus x. So how will the utility function look like? For a utility level of 1, how will the function look like? This is good x, this is good y. 100 minus x is going to pass through 100 and 0 and 0, 100. So this is 100 comma 0 and this is 0 comma 100. This is an indifference curve with a utility level equal to 1. So students, all I have done first of all is I have plotted the indifference curve. This was the utility function given to me. I just took, I know that on the indifference curve, utility is constant. On the IC, utility is always constant. So I fix it equal to u bar. That means I get u bar equals y over 100 minus x. So y comes out as 100 minus x times u bar. Now I just took a value of u bar for simplicity. Let's say u bar is 1, so y is 100 minus x. 100 minus x is a straight line passing through 100 comma 0 and 0 comma 100. Okay, now is it convex? You can clearly see if I take any 2 points A and B, any weighted average of A and B will lie between A and B. Suppose I take a weighted average of A and B, let's say C. C lies on the same level of utility as A and B. So any convex combination of A and B will give the same utility as A or B. So it's convex. It's not strictly convex. I repeat, it is not strictly convex, but it's convex. So you can clearly see that for convex preferences, students can see, since the indifference curve is a downward sloping straight line, since the indifference curve is a downward sloping straight line, therefore any convex combination of A and B, say point C lies between A and B. It can lie anywhere between A and B. And you can clearly see that C yields same level of utility. Point C yields the same level of utility as A and B. The utility you get from point C is the same as the utility you get from A or B. That means I can say, therefore, the preferences are convex. They are not strictly convex, though. I can write in the bracket, not strictly convex. Because strictly convex would mean that C should be strictly preferred over A or B. But in this case, C is indifferent to A or B. That means preferences are convex, but not strictly convex. To check for monotonicity, guys, what do we need to do? Calculate the marginal utilities, MUX and MUY. If I erase this off, let's calculate MUX and MUY. Okay, so what is MUX? It's the partial derivative of the unity function with respect to x. If I differentiate this with respect to x, what do I get? I can use the quotient rule of differentiation. 100 minus x into the derivative of y is 0, minus y into the derivative of 100 minus x is minus 1 over 100 minus x square. What have I used? I've used the quotient rule of differentiation, which I have covered up in my mathematical methods for economics course. So this comes out as this minus and this minus makes it plus. So I get y over 100 minus x square. And this is positive in the first quadrant, because y is also positive and 100 minus x square is always, square of any number is always positive. So MUX is positive. Similarly, guys, MUY will be what? If I erase all this off, MUy is going to be del u by del y. If I partially differentiate the function with respect to y, I just get 1 over 100 minus x, which is positive for x less than 100. You can clearly see that only when x is less than 100, the denominator will be positive. The numerator is anyways positive. For denominator to be positive, x should be less than 100. That means MUI is also positive for x less than 100. So I can say, therefore, preferences are monotonic for x less than 100. My answer is that preferences are monotonic for all values of x less than 100. Okay, so this is my answer. We have shown that the preferences are convex, not strictly convex, but convex. And we have also shown that the preferences are monotonic for all values of x less than 100. Okay, and now let's look at the last part of this particular question. Part 4. U of xy is minus of max of xy. Now let's plot this. If I erase all this off, question 1, part A, part 4. U of xy is minus max of xy. Now, students who have purchased my complete course for intermediate microeconomics part 1, we have discussed in depth how the max function looks like. The behavior of the max function is clearly done in the main lectures. You can clearly recall it's an inverted L-shaped function. Okay, so I can write that u of xy is going to be, so if x is more than y, max of xy will be x, but we have a minus here. So minus x. If x is less than y, max of xy will be y, but we have a minus outside. And if x is equal to y, then it's going to be either minus x or minus y. That means if I draw a picture depicting the max function, this is good x, this is good y, the max function looks like this. It looks like this, and since we have a minus outside, what is the direction of increased utility? Utility is increasing in this direction, guys. For, remember, I can make you write a note. When you have u equal to just max of xy, then my utility increases in the northeast direction. See? Higher indifference curves are in the northeast direction. Northeast direction. But instead of max of xy, if I have minus of max of xy, utility will increase in the southwest direction, the opposite direction. That means my utility curves are increasing in this direction. They are increasing in this direction. Now this is the direction of increase in utility. This is utility from minus of max xy. This is utility from max of xy. I can write here utility increases in the southwest direction. In this, utility increases in the northeast direction. Now, guys, is it convex? Let's check whether it's convex. Let me take 2 points. Point A, point B. Let's join these 2 points. The weighted average, let's say, lies at point C. But you can clearly see that if I take these 2 points, the utility you get from point C is higher than A or B, because C lies on a lower indifference curve. And in case of minus of max of xy, lower the indifference curve, higher the utility. Remember, it's increasing in the southwest direction. You can clearly see that point C is preferred strictly over A or B. So you can clearly see that weighted average of A or B is preferred over A and B. That means the preferences are convex. So I can erase this portion off and I can write this here. If we take a convex combination, if we take a convex combination of A and B, say point C, it lies on a higher indifference curve. It lies on an indifference curve with higher utility. Okay, so suppose the consumer is getting a utility of u1 bar from this, u2 bar from this, and u3 bar from this. Then u3 bar is more than u2 bar is more than u1 bar, because I just pointed out that the direction of increase in utility is the southwest direction. Utility is increasing the southwest direction. That means the more closer I'm going to the origin, the utility is increasing. So I can say that any convex combination of A and B. What is the convex combination? I've again covered this in the mathematical methods for economics course. A convex combination of A and B lies on the line joining A and B. It lies between A and B. So point C is a convex combination of A and B. Point C lies on a higher indifference curve. That means why higher? Because point C lies on U2 bar, and U2 bar gives a higher utility than U1 bar. So I can say that since the convex combination is preferred over the extreme bundles, hence preferences are convex. Hence the preferences are convex. Remember, by definition of convex preferences, averages should always be preferred to extremes, or the weighted average of the two extreme bundles. If I take a weighted average of A and B, suppose call the weighted average as C. C lies on a indifference curve with a higher utility. The utility you get from C is U2 bar, which is more than the utility you get from A or B. The utility you get from A or B is U1 bar. So because the average bundle is preferred over the extreme bundles, preferences are convex. Is it monotonic? So let's find out whether it's monotonic or not. Now let me take another bundle D. Suppose this is D, guys. Now, although C contains less of both the goods compared to D, but still you prefer C over D. So preferences are not monotonic, because monotonic preferences means more is preferred to less. But in this case, you prefer C over D. I am writing it here, although bundle D contains more of both the goods, although bundle D contains more of both good X and Y compared to C, still the consumer prefers bundle C over bundle D. Since utility at bundle C that is U2 bar is more than utility at bundle D, that is U1 bar. Students can clearly see that the utility you get at bundle C is more than the utility you get at bundle D. Although D contains more of both the goods compared to C. So I can say, therefore, preferences are not monotonic. Because if the preferences were monotonic, you should have preferred D over C. My answer is preferences are not monotonic. I am repeating it again. If the preferences were monotonic, you should have preferred D over C, but you don't prefer D over C. You prefer C over D. but C contains less of both the goods. That means it's violating the definition of monotonicity. D contains more of both the goods compared to C. So by monotonicity, you should prefer D over C, but you are not doing that. You are preferring C over D. Hence, preferences are not monotonic. So for this question, preferences are convex, but they are not monotonic. Okay, so with this, we are done with question number 1, part A completely. In this lecture, I have solved part 3 and 4. Now, in the next lecture, we are going to look at question 1, part B. I stop in this lecture. I hope students have enjoyed this lecture. Any doubts? You can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolofeconomics@gmail.com. This is where I stop in this lecture.